anatomy and physiology. Now, what is anatomy? Anatomy focuses on the structure of living organisms. It focuses on things like the appearance and locations of the living organisms. Physiology. Physiology is more to do with the functions of living organisms. This concerns more of how they carry out the chemical and physical structure. The skeleton. Here we have a labeled diagram of the skeleton. Functions and purposes of the skeleton. Support, protection, muscle attachment, blood cell production, store of minerals, movement and shape. Support. The bone supports the body by creating a framework. It holds the organs in place, and also because of our vertebral column, the body is able to stay upright. What this is basically saying is, if you look at our ribs, it protects the organ, and the vertebral column in our back makes sure that we stand upright, because if the vertebral column wasn't there, we would be lounging on the floor like this. Protection. We tend to look at a skeleton as a scary thing, but in actual fact they're very strong and they play a big part when it comes to protection. For example, the cranium located in our head, it is there to protect our brain because it's a very, very hard bone. And we've got the ribs and the sternum to protect the heart and the lungs. Muscle attachment. This also links in with support, because due to the framework of our body, the muscles and tendons and ligaments are able to be attached to the bones. Blood cell productions. Now, when we go further into the types of bones, you see that there's a type of bone called the long bones. And in long bone, we have what we call the bone marrow. And the bone marrow is where blood cells are made. Store of minerals. The bone also stores minerals such as the phosphorus, the calcium, potassium, magnesium, silica, iron, zinc, selenium, boron, sulfur, and chromium. Movement. The muscles are not just attached to the bones just for the sake of attachment. They're there to also create movement. For example, the biceps are attached to the bones here, so I can. That's enabling me to create movement in the arm. Shape. Now, if you look at our bodies, you find that some people are bigger than others, some people are taller, some people are shorter. The reason why this happens is because of the bones. Now that depends on how tall or how short your bone grows. The vertebral column. The first part of the vertebral column is called the cervical. Now, there are 7 parts to it. The second part is called the thoracic. There are 12 parts to it. And in this part, we have the spinal cord and the vertebra. The third part is the lumbar. In between the lumbar, we have discs. And there are 5 parts to the lumbar. The fourth part is the sacral. And it has 5 parts. And the last part, which is like a tail, is called the coccyx. Now there are 2 types of skeleton. We have the axial skeleton and the appendicular skeleton. The axial skeleton. The axial skeleton is mainly in the core of our body, around these parts. And this consists of 80 bones. Why is it there? It's there to protect the vital organs. The appendicular skeleton. The appendicular skeleton has more movement to it. It is also there to protect some of our major organs as well. And this consists of 126 bones. This means the appendicular skeleton makes up more of our skeleton. The different types of bones. We have long bones, we have short bones, we have flat bones, we have irregular bones, we have sesame bones. Long bones. Long bones are the longest bones in our body. Now, you mainly find long bones in your arm, here, the femur, the radius. One thing about long bones is the outer part of the long bones are very hard, and then we have a cancellous bone inside of it, which is very spongy, and it has a lot of bone marrow. Short bones. Short bones are as wide as they are long. Why? Because they have little movement. They are there to provide support and stability. Like, for example, Rowan, if you look at your wrist, the short bones are right here to provide support for the rest of the bones in the arm. They have an outer layer of hard bone as well, but in this case, unlike the long bone, it is very thin, but they have a lot of cancellous bone which has bone marrow as well. Flat bones. Flat bones are strong plates of bones in our bodies. They are there to protect our vital organs because they're very hard. They have a base of muscle attachment. What it's basically trying to say is, if you look at the bone here, under it has muscle attached to it, right? An example of this is the cranium. The cranium is very flat because it's like this. It's joined together, very strong. It's not, you can't break the cranium because of its strong stability. Also, they have cancellous bones that contains bone marrow. And they have a compact bone, but it's thin as well. Sesame bones. These are mainly short or irregular bones. But you find these bones in between your tendons. Why are they there? They're there to provide support. The most obvious one we know is the patella, which is in our knee. Irregular bones. Irregular bones, they fall under no other categories because they don't have a specific shape. And they have a very thin layer of compact bone, but they're formed with cancellous bones. The muscular system. Now, without looking at the board, who can name me some muscles? Yes, Rowan.
Gluteus maximus.
Where's the location of the gluteus maximus, sir?
The bum.
Great. Any other? Yes, Jamercy.
Deltoids.
Deltoids. Where's the location of the deltoids, sir? Thank you very much. Functions of the muscles. There's movements, fixator, synergists, types of contractions. Movement. Antagonistic pairs. Antagonistic pairs create movement when one muscle contracts and the other relaxes. For example, we have a preacher here. He's lifting the weights like this. Now, we can see the bicep contracting. But what is relaxing? The triceps here. Synergists and fixators. The synergist stabilizes the joint to help create effective movement with the agonists. We have the synergist right here. Fixator. The fixator makes sure the origin is fixed to allow effective movement. For example, the fixator for our arm would be here because it's fixed to allow movement. Types of contraction. We have isometric. This occurs when the muscle contraction has no change in length. For example, if I'm holding a stapler in front of me, it's contracting, but there's no change in length because there's enough force for it to be able to hold the stapler. Hole puncher, I meant. Hole puncher. Isotonic. Isotonic contraction is when the muscles change length to produce a movement. Like for example, that preacher's curl. The muscles are changing length to create a type of movement in a part of a body. Now, there are two types of isotonic contraction. Jumesi, can you pay attention, please? Mm-hmm. There is concentric and eccentric. Now, without looking at the board, does anybody know the difference between concentric and eccentric? Bradley?
Oh, no, sorry. I don't know.
Real what?
No, sorry.
Joseph?
Sorry.
Jumesi?
Can you elaborate on this?
Just pointing there. Now, the concentric is when the muscle shortens to create movement. For example, in a bicep curl, you see that the bicep shortened to create that movement. But on the other hand, we have eccentric, which is the opposite of concentric. Now, eccentric is when the muscles lengthen to create movement. It is very, very rare to find this eccentric contraction in sporting activities. But there's one sporting activity that it is used a lot in, which is football. When kicking the ball, we see that our legs extend to create movement and put force into the football. Isokinetic. Isokinetic movement is just like isotonic. But there's one difference. And the difference is, with isokinetic movement, to create movement, they move at the same speed. For example, when swimming, the breaststroke, they move at the same speed like this. When swimming. Fiber taps. Tap on fiber. These are known as fast twitch fiber. They are red in colour and they produce a low level contraction. Type 2A. These are known as a fast oxidative fiber. They contain a large number of mitochondria and myoglobin, just like type 1. That's why they are red in colour as well. Now, the one that differs from the rest of them is type 2B. These are white in colour. Why? Because they have low level of what type 1 and 2A have, which is myoglobin and mitochondria. They are mainly found in the arms. That's why you see when runners are running, they use their arms to stroke through the air. Yes, sir?
Can you tell me what mitochondria is, please?
Oh, mitochondria, myoglobin. I would elaborate on that, but I haven't got enough time to. So yeah.
No, we've got 15 minutes left, so sorry.
Oh, we have. I didn't realise. Now, what mitochondria is and myoglobin are, they are found in our muscles, and
so
this is, wait, I haven't finished it. Mitochondria and myoglobin, you find them in type 1 and type 2A fibers, linked in with oxygen because they create that red colour. Thank you very much. These are my references. Thank you, miss.
That was even right.
I don't know what my